we can't deny it. Webb is a marvel. Just months after its launch, the James Webb Space Telescope is already refining our understanding of the universe and expanding our knowledge of the cosmos. One of the primary objectives of this telescope is to look back in time to the universe's earliest days and reveal the secrets of our existence. NASA has stated that Webb will enable groundbreaking discoveries in our quest to understand the universe and humanity's place within it. Webb will conduct ultra-deep near-infrared surveys to identify the first galaxies and learn how the universe evolved into what we see today. With Webb, we will see farther back in time than ever before. We won't just be looking at the universe as it is now. We'll also get to see how it was in the past. But what exactly does it mean to look back in time? Well, it's just as it sounds. Because light takes time to travel, the farther away a celestial body is, the farther back in time we are seeing it. Light from the sun takes about 8 minutes to reach Earth. It takes hundreds of thousands of years for light from distant galaxies to reach us. So when we observe distant galaxies, we're looking back in time to a period from hundreds of thousands of years ago. This is why astronomers are excited to use Webb to look back to the universe's first galaxies and learn how it evolved into what we know today. By observing the universe in the infrared spectrum, Webb will be able to witness the faint signals from the first galaxies that formed after the Big Bang. These galaxies are incredibly distant, and their light has been stretched by the expansion of the universe, making them appear redder and fainter, a phenomenon known as redshift. This is where Webb's infrared capabilities come into play. Webb is specifically designed to detect the infrared light from these distant galaxies. Its advanced detectors are extremely sensitive and can pick up even the faintest signals. One of Webb's first targets was an ultra-deep field in the early release observations. This region of space was chosen because it is incredibly distant and has not been observed in such detail before. Webb was able to identify thousands of galaxies in this field, some of which were seen as they were just a few 100 million years after the Big Bang. These galaxies are incredibly faint, and it is unlikely that they would have been visible to any other telescope. This is just a tiny sample of what Webb can do over the course of its mission. Webb will conduct numerous ultra-deep field surveys to map the distribution and properties of the earliest galaxies in the universe. It will also observe galaxies at various stages of evolution to better understand how they formed and assembled. Now, let's take a look at one of Webb's most fascinating discoveries. In a recent discovery, Webb has managed to peer through the thick layers of dust shrouding one of these infant galaxies and has seen something that has shocked astronomers. Within this galaxy, Webb has spotted a supermassive black hole lurking at its core. How did Webb manage to spot a black hole through all that dust? Well, it's all about perspective. Thanks to Webb's superior infrared imaging capability, it was able to identify hot dust in the galaxy's core. This dust was heated to incredible temperatures, indicating the presence of a blazing hot black hole located just 210 million light-years away. But that's not all. The team also detected water in the galaxy's outer regions. This was a complete surprise, as it was the first time water had been discovered orbiting a black hole. The amount of water detected was equivalent to over 3 trillion times the mass of our moon. And here's the kicker. Despite the intense heat and radiation emanating from the galaxy's center, the water remained in place. This discovery was nothing short of remarkable, and it has raised many questions about the formation and evolution of supermassive black holes. Astronomers had long wondered how these enormous black holes grew to their colossal sizes. And this discovery suggests that they may have started out as relatively small objects that gradually consumed surrounding material. Webb is equipped with advanced instruments that allow it to observe a wide range of celestial objects and phenomena. One of its key instruments is the Near-Infrared Camera, or NIRCam, which allows Webb to see some of the earliest galaxies in the universe. Webb's NIRCam has 4 different instruments that work together to capture images in the near-infrared spectrum. Together, these instruments can detect light from some of the universe's oldest stars and galaxies. Webb's mid-infrared instrument, or MIRI, allows it to detect light in the mid-infrared spectrum. This is particularly useful for observing objects that are obscured by dust, such as young stars and planets. Webb's Fine Guidance Sensor, or FGS, is used to guide and stabilize the telescope. It also works as a near-infrared imager and spectrometer, allowing Webb to capture sharp images of celestial objects and analyze their spectra. Webb's near-infrared spectrograph, or NIRSpec, allows Webb to analyze the spectra of celestial objects in the near-infrared spectrum. This helps astronomers learn more about the composition and properties of these objects. Webb's instruments are truly remarkable and allow it to conduct groundbreaking research on a wide range of topics, from the birth of stars to the death of galaxies. As Webb continues its mission, it is expected to make many more groundbreaking discoveries that will expand our understanding of the universe. But amidst these amazing discoveries, there's a lingering question. Is Webb our universe's last hope? There's an unsettling feeling that permeates the scientific community, a dawning realization that Webb may be our final chance to explore the cosmos in this manner. Some argue that the James Webb Space Telescope represents the pinnacle of human ambition and engineering brilliance, but also the end of an era. We've reached a point where constructing and launching telescopes of this magnitude is increasingly challenging, and as a result, Webb may be the last of its kind for the foreseeable future. Imagine gazing up at the night sky filled with wonder and curiosity. See the moon, Mars, and the bright constellations, each twinkling with its own unique beauty. But what if you could see beyond the naked eye, deep into the heart of space where wonders beyond imagination lie hidden? That's precisely what the James Webb Space Telescope is offering us. A glimpse into the universe's most intimate secrets. What sets Webb apart is its location. Unlike its predecessors, Webb is positioned not in Earth's orbit, but at a strategic point beyond the Moon. This unique vantage point, known as Lagrange Point 2, or L2, provides several advantages. Webb remains in a constant state of free fall around the Sun, in sync with the Earth, ensuring continuous sunlight and uninterrupted observation without interference from the planet. Furthermore, L2 allows Webb to maintain a cool temperature, crucial for its advanced instruments to function optimally. The significance of Webb's location cannot be overstated. It enables the telescope to remain operational for years without the need for lengthy and costly repair missions. By positioning Webb at L2, we've ensured that we have access to its groundbreaking capabilities for a prolonged period. Webb's exceptional performance extends to its targeting accuracy. Equipped with a sophisticated guidance system, Webb can lock onto celestial bodies with unmatched precision. This is particularly advantageous when dealing with dim, distant objects that require extended periods of observation. Webb's ability to maintain a stable focus on its targets ensures that we can collect detailed data and imagery, enriching our understanding of the universe. But the marvels of Webb don't end at its location and targeting capabilities. The telescope's primary